All right. So before I kind of jump into things here, and this is the first slide in that module 4 skeleton slides on Canvas. I'm going to take like the first 5 minutes of class. You can scan this QR code, or if not working from out there, try to pull open the slides. Use that first slide that kind of has this information to kind of complete this survey for me. All right. I mentioned this last class. This is going to be a way that I kind of give you guys 3 surveys throughout the semester, trying to collect information. Hopefully makes me better at what I'm doing. Me being better at what I'm doing makes it better for you guys, right? It makes it, you're learning more. So you take the 5 minutes or so to kind of get this survey done. I'll kind of check in about 5 minutes, and then we'll kind of start with the material for the day. We should have more than enough time to kind of get through everything, which is why I saved this for today instead of Tuesday's class. Okay, so get on and get this QR code scanned, or I think you can use the link, kind of fill out this. Is this working? Some of you, is it pulling up for you? Just to double check. Is anyone getting this to pull up yet? Give me a hand in the air, thumbs up. Awesome. All right, so I'll check in about 5 minutes. We'll kind of see where you guys are at with this. It shouldn't be super long. And then we'll kind of get going. So it should just be like a Qualtrics survey. I think they did it through. Many of us got it done. How many people are still working on it? A couple people? Okay. So I'll give you a couple more minutes here. Take your time. We're going to start out not jumping right into material anyways. I'll kind of recap some stuff about the class. So just to kind of set us up, I pulled open something to mention, but I've got down here today, we'll have another in-class quiz. We'll use it at some point throughout the class period. So yeah, Tuesdays, I use it at the beginning to kind of get used to. It's not always going to be at the very end of class, right? So making sure we're here the entire class to make sure we know when that quiz is released. And so the due time is not always going to be 9:15. It might be whenever I use it in class. Right? So you've got your practice problems for the module 4 quiz this week. All right, that'll kind of pop up after my second section. So right around 11:15, you'll see that module 4 quiz pop up. We don't have a module reading because next Thursday, is the exam in class, right? Paper and pencil, okay? So this was outlined day 1. It's in the syllabus. Excuse me, but the exam will be in class next Thursday. Tuesday, we'll primarily be doing a review day. So I'm thinking we'll get through all of module 4 material today. There might be something I revisit at the beginning of Tuesday's class, but for the most part, it's going to be review. And the thing that I'm really going to focus on is any questions that you guys have or any problems in this set of practice problems, right? So I kind of have this practice exam up. It's not completely like a mirror of the exam. The exam's going to be 25 questions. This is 20. So the remaining questions, some of them are going to come from module 1. So there's not really any material for module 1 in here. So what would I study for module 1 questions? What's some resources you have that have the types of questions I was asking you in module 1? The module 1 quiz and module 1 practice problems, right? So every module, you've got practice problems and quiz questions you can review. Now, those quiz questions, you can't see it. You can see 1, 2, and 3. You won't be able to see 4 until after Monday, after the due date. But you'll have all of those to review. You'll also have these practice problems, which we'll kind of review quite a few of them in class on Tuesday. I would kind of start out as my hierarchy, practice exam questions, quiz questions, especially the ones that I got wrong. And people are emailing me, asking me how to study. I'm outlining it right now. So if you ask me, this is a good thing to write down. Then I would kind of review the quiz questions, even the ones I got right. Then I would go to kind of reviewing those practice problems. That would be the order I kind of go. If I still want to look at more problems, where's somewhere else I can find more problems? Even though we go through them in class, I make them low stakes. A lot of the questions we use for these in-class quizzes are the types of questions I could ask you on the exams. It's just on the exam, they're a little bit more high stakes because we've got less time per question. They're worth points. I'm not walking you through some of them, right? So those are other good questions to kind of go back and review, right? So that would be kind of my hierarchy of things that I use to study. And then on top of that, if you want to, I'd go back through my notes after that. Now, obviously, you can go back through your notes as well. But in terms of I'm going to be asking you questions, the types of questions you'll see are all represented in those types of materials. Okay, does that make sense? Any questions on that? We'll talk more about the exam specifics on Tuesday's class, but I'm just kind of setting this up where we're going. Another questions I've been getting a decent amount of, and I talked about this a while back now, which was this pack-back assignment, right? So I said, I kind of gave you this. If you're having any problems with the links, sometimes if you're viewing this from Canvas has weird pop-up things. So just in terms of pack-back, I would always go to packback.co. That's the kind of link that I put in that first week of slides. Instead of going through Canvas, going directly there and using it on their platform as opposed to like the embedded platform on Canvas, those links should work fine. So I've got 2 articles, right, which are not really that long. They're kind of meant for the general public. They're pretty easy reads. You don't have to go through them with a fine-tooth comb. I kind of summarized what they're talking about here. This MIT article, someone asked me, do I need to read through it? It's like 15 pages. It's pretty dense. I'm not expecting that you kind of go through that, read that with a fine-tooth comb. If you want to read the summary or my summary of it, it just kind of gives you an idea about this topic of kind of how ChatGPT is impacting economies in terms of their capital investment, productivity. You're then going to respond to this prompt with whatever you find. You don't have to respond to every question I ask, every topic, just what you find the most interesting or you think you have the most insights into. If you've already done this, I apologize, right? But the way you do that is you hit this big red button, That's your initial response or your initial question to my guidepost. I said, try to end these with what? So when you write your initial response, try to end it with a, what is it called? A question of your own, trying to kind of keep this a possibility for discourse, because after you post your initial response, what else do you have to do? Respond to two other people's, right? So kind of ending your initial post with a question at the end kind of helps facilitate some of this responses from your other students, okay? So this is due by the end of the day tomorrow. So if you haven't done this, make sure you're getting on and getting this done. I don't want to be getting emails at, 1 a.m. on Saturday, right? This is a hard due date, okay? So that pack back assignment's due Friday. You'll see that 4th module quiz pop up. That'll be due by the end of the day. Quizzes are always due at the end of the day on Monday, okay? So that's kind of just housekeeping stuff, where we're at in the class. Other than that, we should be ready to kind of jump back into material where we left off on Tuesday, unless there's any questions for me before we get going here. No questions? Okay. All right. So, just to kind of remind us where we're at, we ended class talking about some of the different traits that impact the price elasticity of demand. So we said the price elasticity of demand really meant what? How responsive is supply and demanded to changes in the price of the good, right? Elasticity meant kind of responsiveness, okay? So the price is changing. How are consumers responding with how much they want to buy? There's a less technical way maybe of saying it. So we talked about some of the things that make it more elastic or more responsive is if I have more time, if it's a larger portion of my income, right? And if I have more substitutes. Right? So if I think about different types of goods, I'll point out a couple on this list. So economists love to measure price elasticity of demand. I grabbed these from, I think it was, I don't know if it was the BLS, one of the government agencies, economic agencies. But you'll notice for things that are very inelastic, right? Something that there's not a lot of substitutes. If I'm addicted to smoking cigarettes, there are some substitutes, I guess, right? I guess I could use Zins or some other nicotine product, right? But if I really like smoking, right, there's something very relaxing to me. Notice for tobacco products, what would the price elasticity of demand be? If they increase the price, I don't have a substitute if I really want to smoke a cigarette, so I'm going to keep consuming the same amount. So I'm going to be pretty unresponsive. Our inelasticity measure, sure enough, is really close to 0, right? 0.1. Airline industries in the short run. So I forget how to define short run. It was like I have to leave within the week. Well, if I don't have a lot of time, I need to be somewhere in a couple of days. They can increase the price of an airline ticket, and I'm going to have to do what? Still buy it, right? My demand can't respond much. Sure enough, short run airline industry tickets or short run airline tickets, pretty inelastic. Long run, when I have more time, what happens to those same product, just changing the feature of how much time I have, becomes elastic, right? Greater than 1. And then you think about something I'm spending a large portion of my income on, automobiles, pretty elastic. Now, even though it's not a large portion of my income, and I probably have some time to figure out where I want to go, why would restaurant meals be pretty elastic? What is there a lot of? Substitutes. So there's a lot of restaurants, right? So all these features will kind of play a role, right? I think I found this one. I thought it was interesting. I don't know if it's interesting, but we have price elasticity measures for I don't know, really good, whiskeys, brandies. People are fairly inelastic. I guess if I really want a high quality whiskey, I don't want to substitute away from that, getting something else. And so I'm pretty inelastic. Whereas when we're looking at just pre-mixed drinks, you can just get anywhere there's garbage, mostly there's hardly any liquor in them. People are pretty elastic to those. So even the same product, but slightly different, right? Slightly different features here. We can see different elasticity measures. So this is kind of where we left off, just thinking about this price elasticity of demand. We also talked about slope and elasticity are related, but not the same. We said if I have perfectly inelastic demand, what did that look like visually on a graph? So I'm not responding to prices at all. Someone did it. Completely vertical line, right? The price can change I keep buying the same amount. Perfectly inelastic. What would the slope of a vertical curve be, a line? So it's kind of weird. The slope would actually be infinite, right? So they're complete opposites. The slope is, infinite, but if I had perfectly inelastic demand, the elasticity of demand would be 0. I'm completely unresponsive. That's one way to remember what inelastic is. It's closer to 0, it means I'm not responding at all. The further I get away from 0, the more and more elastic my demand is. So what ends up being true is not only do we have this relationship that's kind of inverse between elasticity and slope, I have different elasticity measures at different portions of my demand curve. So I'll kind of give you some insight as to why. And I won't go through the exact mathematics, but I think what you'll see, you'll kind of get what I'm getting at here without breaking this down and entering it into a calculator. So let's say I've got some product. And initially, if I lower the price from 100 to 99, the quantity demanded goes up from 1 to 2. Now, instead of using the midpoint method here, I'm going to kind of use like a non-midpoint method, but you can kind of think about what would a reduction from 100 to 99 be close to in terms of a percentage? A decrease of about 1%, right? So my percent change in price here is about 1%. What's my increase in quantity demanded? Well, if I go from 1 to 2, it doubles. So that would be a percentage change of approximately, something doubles, it's a 100% increase. So what would my elasticity of demand be on this portion of my demand curve? Well, it's the percent change in my quantity demanded divided by the percent change in price. So I'm getting about what? 100? This is a really elastic demand, right? So anytime I'm starting out like at that highest point of my demand curve, or the highest portion of my demand curve represents what? When I am buying a really low quantity of that good. So the first few units of that good, if I don't have any, I'm going to be pretty, or here we would have, sorry, I flipped, no, I got this right? I'd be pretty elastic, right? So I'm pretty responsive to those price changes initially. Now, once I get down here, what if I had the reverse kind of being true? All right, so I'm going from like $2 to $1. Approximately what would that percentage change in my price be going from 2 to 1? Well, it's getting cut in half. So it'd be kind of like a 50% decrease. How many more units am I buying? Once again, just rough estimate, going from 99 to 100 would be about what? Approximately 1%, right? So what would my elasticity measure be on the lower portion of my demand curve? Well, once again, it's the percentage change in my quantity demanded over my percentage change in price. I'm getting what, 1/50th or point, oh, what is this, 0.005? Really low. So no, that's not 0.005. It's even lower, right? It's something very close to 0, right? So as I move down my demand curve, what happens? I start out, it's initially elastic. As I move to lower prices, higher quantities, this portion of my demand curve is going to be 1/50 is less than 1. So we would say it is inelastic. So as a rule of thumb, our demand curve starts out as elastic, and as we move down that demand curve, it becomes inelastic. Okay. Any questions on this idea before we keep moving here? Okay. So if I'm going from elastic to inelastic, right? And this relationship kind of, it exists the whole way. It doesn't, I chose the two extremes, but as I move down, this is getting lower and lower and lower. There will be a point where my elasticity of demand is what? There was one other range we said it doesn't happen very often. We can have elastic, inelastic, or, which would be an elasticity measure of 1. All right. So I'm going to have this elasticity of demand that changes at different portions on the same demand curve. So I think in the slides, I've got some slightly different examples or numbers, and I actually use the midpoint method here. So if I actually were to calculate that movement between $30 and $20, my quantity goes from 0 to 20. How do we use the midpoint method? If I want to find a percentage change, I'll do what? So if I want to find the percentage change in price, I take the change in price and I divide it by, I think someone said it, the average price between those 2 points, right? So that's how I'm kind of coming up with these values. If I were to kind of keep lowering the price, I eventually see there's a portion of my demand curve in the middle where the percent change in the quantity demanded is the exact same as the percent change in price. So my demand would be unit elastic. And then if I continue to think about decreases in the price, right, I eventually get to this point where that percentage change in my quantity demanded is less than the percentage change in price, and I end up having, I'm on the inelastic portion of my demand curve. Once again, if you wanted to, you could reproduce these values using these numbers, but that same $10 decrease, right? It was the same change in price, but as I move down my demand curve, that's going to represent a larger and larger percentage change. So because that percentage change in price is in our denominator, right, 40, 67, 200, our elasticity of demand is becoming more and more inelastic from that same $10 decrease. Okay. Any questions before we keep moving here? We're going to use this idea that the elasticity is different at different points on my demand curve. So why do we care that it's different at different points on the curve, right? Well, as a company, I care about this, and consumers care because it's directly related to revenues. We'll think about why here, okay? So I think I'll set this up initially, right? Why do we care about this? Well, if total revenue is price times quantity, why would I want as a company, why would I hope demand is inelastic? If I'm thinking about lowering the price, well, if I lower the price, what is that going to do to my total revenues? It's going to go down, right? If total revenue is just the price I can sell the good for times the quantity I sell, well, that's a bad thing if I lower the price. However, if people are fairly elastic when I lower the price, what's going to happen to how many units they buy? It's going to go up by, they're very elastic, small changes in price or small decreases in price would change the amount they buy by a lot. Well, what's that huge increase in quantity going to do? It's going to increase my total revenues. So whether or not I'm increasing or decreasing the price, right, I care if demand is elastic or inelastic. Right? So I'll kind of give you another way of thinking about this. I think it helps using arrows, right? So I'm going to set this up as total revenue is price times quantity, okay? So I'm just going to do this for price decreases. Right? Everything would work the exact opposite if I wanted to increase the price. So let's think about if I had elastic demand, right? If I have elastic demand, what's true about my percentage change in the quantity demanded relative to the percentage change in price? Well, remember, my elasticity of demand is the percentage change in the quantity demanded over my percentage change in price. So if this is greater than 1, which of these has to be larger? Yeah, the percentage change in quantity demanded. So if I'm thinking about how is total revenue going to change if I were to lower the price, right? So if I'm lowering the price here a little bit, maybe I'm decreasing the price by, I don't know, 10%. What percentage change in quantity demanded am I going to get? Something that is, so if I know it's elastic and I lower the price by 10%, the percentage change in quantity demanded has to be not a specific value, but greater than. What does X have to be? Greater than 10. I know you guys all have the prerequisite in math to be in this class that you should hopefully be able to understand this, right? The only way a fraction is greater than 1 is if the numerator is larger than the denominator. So if I know that demand is elastic, that percentage change in price, I know the percentage change in the quantity demanded has to be greater than that. So even though I was hurting my total revenues here when I lowered the price, what response was I getting from demand? Something that was even larger. So when I lowered the price, if consumers are elastic, I'm getting a much larger increase in how many units they're buying. So what does that do to total revenues? Increases them. Well, I don't have numbers here, but I tried to draw the arrows kind of to represent the magnitude. What's going to happen overall to my total revenues? That decrease in price decreased them a little bit, but it was increased a lot by the fact that people were buying way more. So you can kind of think about the overall total effect here of a price decrease was my total revenues are going to go up. I'm trying to draw these, these arrows to kind of represent those magnitudes. Okay. Does that make sense, or any questions on that? Kind of give you the easiest idea. Let's say I'm selling something for $1 and I'm selling 10 units. What would my total revenue be? $10, right? 1 times 10. Let's say I lower the price to 50 cents, but now I'm selling 100 units, right? How much would I be making? 100 times 0.5 or $50. So I lowered the price, but people bought way more. If demand is really elastic, lowering the price, I'll actually increase my total revenues. Okay? Now we can do the exact same thing thinking about what if demand is inelastic? Okay. Well, if demand is inelastic, what has to be true about that percentage change in the quantity demanded relative to the percentage change in price? Well, if it's less than 1, what has to be larger, the numerator or the denominator? The denominator, which is my percentage change in price. So here, if I had inelastic demand, I could lower the price by a large amount. I don't know if you want to put a value to this. I don't know, like 50%. But the response I get from demand might only be 10%. Or, yeah, people buy more, but not that much more. So if demand is inelastic, what's going to happen to total revenues here when I lower the price? Which of these arrows is larger? Are our eyes working? Which of these arrows is larger? The price decrease. So what's going to happen to my total revenues? They're going to go down, right? That's going to be the effect that kind of wins out, all right? Overtakes that increase occurring from the quantity demanded. Okay. Questions on that? Once again, I mean, I might ask you these questions. I like to draw arrows like this, thinking about, oh, well, if I know the percent change in quantity demand, let me draw that arrow larger than the percent change in price. I know that relationship already. This gives me kind of a nice visual about what's happening with total revenues when I'm lowering the price when demand is elastic versus when it's inelastic. Yeah.
Price went up, if the customers are inelastic, would they still pay with the same amount of product?
So the price went up and they're inelastic. So you could do a very similar thing, right? So let's say I've got inelastic demand. I know this is still true, right? Well, now what's happening to total revenues if I increase the price? Well, I know I could, if it's inelastic, I could change the price by a lot. And what would happen to the quantity demanded? It would go up by only by I'm increasing the price now. So I increase the price. I know that they're going to buy less, but I know that change is going to be relatively small. So if I have inelastic demand and I increase the price, what's going to happen to my total revenues here? Yeah, they're going to go up, right? Now that percent change in price is going to be the effect that's large. So it worked the exact opposite, right? So decreases in price when it's inelastic will decrease my total revenue. Increases in price when it's inelastic will increase total revenue. And just intuitively, it kind of makes sense. If people aren't responsive to price changes, like let's think about the extreme. If they're perfectly inelastic, what happens when I raise the price? People keep buying perfectly inelastic. If I raise the price, people keep buying the same amount. So what's happening to the quantity demanded? It's the same. What's happening to how much I'm selling every unit for? Goes up, total revenue will definitely go up. So if it helps to think about like that extreme, perfectly inelastic, to kind of get at this idea, that can also be a good way to think about it. Okay. Any other questions on this before we keep moving here? Let me make sure before I go back to the slides, there's nothing else I want to do on here for us. Oh, let's see. Oh, there is one more thing I wanted to do, although I don't think it's that crazy. If I had unit elastic demand, what's going to be true about my percentage change in the quantity demanded relative to my percentage change in price? The exact same. So if I were to do kind of a similar thought experiment, if I lower the price, what's going to happen to the change in the quantity demanded? It's going to be perfectly offsetting, right? It'd be the exact same change. So what's going to happen to my total revenues at that unit elastic point if I change the price? Unchanged, right? Now, the unit elastic point is going to be like a very small portion of the demand curve. So if we decrease or increase the price by too much, we're going to move to the inelastic or elastic portion. But that would be true if we had unit elastic demand. Minute changes in price there shouldn't change our total revenues. Okay. Any questions on this before we keep moving? So this is where sometimes I think it makes sense to deviate from what I was going to do and kind of show you. So we have this relationship. I want to try to graph this out for you, okay? And like I said, I'm jumping the gun a little bit, but I think it makes sense. And then some of the slides will look a little bit more like review of what we're now talking about. But I think seeing me like build these helps, right? So we said that initially, when I'm on the high portion of my demand curve, what did we say demand starts out as? Elastic, right? So this was because when I start out at 0, any change in my quantity demand is going to be a large percentage change. So my numerator is going to be a very large value. Now, when I move to lower parts of my demand curve, we said that demand starts to become inelastic. And there will be a portion of my demand curve in the middle that is unit elastic. So I'm going to try to map out, and this is a good thing if I ask you questions about what's happening to total revenue. So we got to think about this as dollars or total revenue now on my y-axis. So I'm trying to map out these different quantities and the corresponding prices to what my total revenue would be at these quantities if I charge these different prices. So we said, well, let's think about the easiest one. If I sell 0 units, what's my total revenue? 0, right? Price times quantity, 0 times anything is 0. So as I start to lower the price, when demand is elastic, what did we say is happening to total revenues? As I lower the price, small percent change in the price lead to large percent change in the quantity demanded. So what was happening overall to total revenue? It was going up. So as I lower the price, I'm selling more units. What's happening to total revenues? They're increasing. Now, when we get to this unit elastic point, this is going to be a very small portion of the demand curve. And I said there, if we change the price, total revenues would kind of stay the same. Really, in practice, when we have nice continuous lines, this is going to be where total revenue is maximized, right? At that unit elastic point, that is the highest possible we can get total revenue. Why? Because if I start to lower the price from that unit elastic point, what portion of the demand curve am I now on? The inelastic portion. If we have inelastic demand and I'm lowering the price, selling more units, what's now happening to my total revenues? They're now decreasing, right? So this relationship between the price I'm setting, right, because that's going to impact how many units people are buying, based off the elasticity of demand, we can map that out onto what's happening to total revenue. So if I'm a company, I really want to know this, right? Because I look at my product like, should I increase the price or should I decrease the price? Well, if demand is inelastic, let's say I'm that I'm a tobacco company, right? And demand is inelastic. I'm on the inelastic portion of the demand curve. Do I want to lower the price? Well, if I'm on the inelastic portion, I lower the price, what's going to happen to my total revenues? They're going to go down. So if I'm a tobacco company, what do I want to do to my prices? Increase them, right? If I increase prices, move up this way, now what's happening to my total revenues? Yeah, I'm selling fewer units, all right? I know that when demand is inelastic, increasing the price will actually increase total revenue. So no matter where I'm at on that demand curve, no matter if it's elastic or inelastic, the direction I want to change the price. So elastic, I want to decrease it. Inelastic, I want to increase it. Why? Because if I move towards the unit elastic point, what's happening to total revenues? They're getting closer and closer to their maximum. Right? Now, obviously, we haven't factored in costs of the company here yet, but if we're just thinking about maximizing total revenues, so like a lot of times nonprofits are maximizing profits, they might be maximizing revenues. If their costs are being covered by somebody else, they act as though they don't have any costs. So this is just a small piece of the puzzle once we get to think about what firms will do, but they do care about this, right? Because the direction in which total revenues will change depends on if I'm on the elastic or inelastic portion of the demand curve. Okay? Any questions on that before we keep moving here? Okay with this? Yeah. Yeah, so like in practice, if it's a continuous line, it's very hard to like get to that exactly to that unit elastic point, right? It may be technically, if I'm thinking about price changes, like technically I'm limited to like a penny, right? But even if I like only make changes, maybe it's like slightly flat up here. Like there might be a very small range of quantities where it's unit elastic, but in theory, it really would end up being like one specific point. So if we're making decisions as a company, we're never usually going to be, it's hard to get the price to be exactly equal to that, right? But we can move towards it, right? Which is what we care about, right? Because in theory, it could be that that point is, you know, $5 and 1.3568974 cents or something like that, right? But we can't, we're limited to that second decimal. So we're just getting as close to that point as possible. Is that what you were getting at? Yeah. Other questions on this before we jump back over to the slides here? All right. So I've got like a little toy example here. We've already talked about all these principles, but you can actually go through, use the midpoint method, and a very simple demand curve where I'm going lowering the price by $1, increasing the price, or sorry, increasing the quantity by 1 unit. Well, notice initially that percentage change in price is going to be relatively small compared to that percentage change in my quantity demanded. So I'm going to start out, and here I didn't take the absolute value, so all my price elasticities are negative. In practice, when I ask you for this, we always look at the absolute value. But technically, this relationship between price and quantity, right, is inverse. Right? So you'll notice here we start out at high prices at that top part of the demand curve. We calculate these elasticities, it starts out as very elastic. As we lower the price, move down that demand curve, we're getting closer and closer to the unit elastic point, which means my elasticity is getting closer and closer to 1, or in this case, -1, right? So we're getting slightly less elastic demand. We lower it enough, we get to that unit elastic point. If we continue to lower it, move to the lower parts of our demand curve, demand starts to become more and more inelastic. This is something we already talked about, but you can kind of see it play out with actual values as well. If you use that midpoint method, calculate these percent changes. No, so if I asked you to find like the elasticity specifically of a demand, like one specific demand curve, I'd ask you to find the elasticity of a specific portion of that demand curve. So moving between 2 points, which how would we do that? We use the midpoint method we talked about last class. So I'm only going to ask you between these 2 prices, what would be the elasticity of demand? Okay. Any other questions here before I keep on going? What else do I want to say here? I kind of already did this for us, but I'll show you in a slightly different way. So we already graphed out this relationship between higher and lower prices and what that's going to do to total revenue. Got a slightly different way of showing that to you. Okay. So let's say I start out with this very simple kind of price from 0 to 5 and quantity from 0 to 5, just to make the numbers easier to deal with. Let's say I lower the price from $4 to $3. So when I was charging a price of $4, what was my total revenue? If I charged $4, what was the quantity demanded? 1. So my total revenue would be price times quantity, or 1 times 4, so $4. If I lower the price by $1, what's happening to that first unit I sell? I'm losing $1 on it, right? I'm still selling it, but I'm now only selling it for $3 when I lower the price. So I lost $1 of revenue. However, when I lowered the price, what did I convince this consumer to do? Buy an additional unit. How much money am I making on the second unit? Well, if I'm selling it for $3, how much did I make on the second unit? Well, at total, I made 6. Well, on the second unit, I made another $3. So what was happening? I gained $3 from selling that second unit. I lost $1 on the first. What's my net gain there? Total revenue should go up by $2. Sure enough, our total revenue before was 4. Now what's my total revenue? I'm selling 2 units at $3. My total revenue is 6. Total revenues went up by 2. So here I know that demand must be what? When I lowered the price, total revenues went up. So I know demand has to be elastic. Right? That was kind of that relationship that we drew out up here. Now, if I keep lowering the price, right? So let's say I lower the price from $3 to $2. How much am I losing on those first 2 units I was selling before? I was selling them for $3. I'm now only selling them for 2. So on each one, I lost $1, or a total of $2 lost in total revenue. But when I lower the price to 2, I convince the consumer to buy 1 more unit. How much am I making now by selling that 3rd unit? Well, if I'm selling just on the 3rd unit. So if I sell that 3rd unit, I'm charging a price of 2, I made an additional $2. So I lost 2, I gained 2. What happened to my total revenues? They didn't change at all, right? So now what are my total revenues? Well, I'm selling 3 units at this new lower price of $2. Total revenues would be 2 times 3, or 6. That's what they were before when we had that price of 3. So if total revenues didn't change and I lowered the price, what must be true about that portion of the demand curve? We're on the unit elastic portion, right? So we kind of continue with this. If I then, well, I should have moved my arrow, but if I'm lowering the price from now $2 to $1, I was selling 3 units before, but when I lower the price to 1, how much am I losing on each unit? Each unit, I'm losing $1, right? Well, I was selling 3 before, so what's the total amount lost? $3 of revenue. But by lowering the price, I know I can convince the consumer to buy more. They bought 1 more unit, but the price is only $1, so how much did I make on that 4th unit? Well, I only sold it for $1, so I only made $1. What's my net gain here? Well, I lost $3, I made 1. Overall, I lost $2. So what happened to total revenues here? They decreased, which tells us we must be on the inelastic portion of our demand curve. And what would total revenues be if I lower the price to 1? Price times quantity, 1 times 4 would be $4. Sure enough, total revenue went from 6 to 4, or has decreased. So very simple numbers, I guess, easier example here that kind of conveys to us this relationship that when demand was elastic, lowering the price, the whole idea is like when I lower the price, yeah, I'm making less per unit, and that hurts my total revenues. But if I'm selling a lot more units, that can compensate for that, right? Lowering the price, making less on each unit, I'm okay with that as long as I'm selling a lot more units, right? So this is the idea. When is that going to be the case? When demand is elastic, right? Now, when demand is inelastic, by lowering the price, I'm making less on each unit. But if people are inelastic, when I lower the price, how much more do they buy? inelastic means they're pretty unresponsive. So they're not going to buy that much more. So lowering the price, I'm just making less on each unit and I'm not really selling that many more units. So my total revenues are going to go down. So just a slightly different way of kind of seeing this relationship between price, elasticity, and total revenues. Okay. Any questions on that before we keep on moving here? Okay. I jumped the gun and already drew this out for us, right? This relationship between elasticity, price changes, and total revenues. I've got some questions here that we'll eventually go through, but I think I'm going to pull this open and just think about how we could use some like actual kind of data here. So, now, do I want to do this? We'll do this if we have time at the end. I don't want to confuse you or waste class time on things that I may not necessarily ask you on the exam. So I'm not going to ask you to use Excel. So that's kind of above and beyond additional. If we have time, I'm going to show you, we can actually use data, data file, prices and quantities, and actually come up with what elasticities are and think about this relationship between revenue and elasticity. If we don't have time for it today, I might start kind of Tuesday's class with it and then kind of jump into review afterwards. It'll be a nice way to kind of start out reviewing price elasticity of demand. So the other things that we want to talk about today is not just the price elasticity of demand, but it's going to be things like cross price elasticities, or if I have the price elasticity of demand, what do you think I also have? The price elasticity of supply. Right? So we'll first start out thinking about these cross price elasticities. So my cross price elasticity is going to look very similar to my price elasticity of demand. However, it's going to measure how responsive were consumers in their consumption of good X when the price of good Y changed, right? So, right, cross price. So this cross price elasticity, what do you think it's going to allow me to figure out? If two goods are what? Substitutes or complements, right? So if we think about my cross price elasticity, so when I say cross price, so here I'll kind of write this out. So cross price, and we're only going to talk about it in terms of demand. So remember, the first word is the thing that's changing, right? So that was in our price elasticity of demand, that was just the price of good X. Well, instead of the price elasticity of demand, I have the cross price elasticity. So now it's not the price in good X that's changing, it's a cross price. It's looking at a different good. So it's when the price of some other good Y changes, how is the quantity demanded of good X responding to that? So if I have substitutes, right? So let's think about, well, I'll color code it. If the price of some other good goes up, and as a result, I buy more of good X, what must be true about those two goods? So if the price of another good goes up, and as a result, I buy more of good X, those two goods must have been what? Substitutes, right? So you can kind of try to think about something that would fit this example. So like, let's say the price of, this was like the example for a street corner and one gas station, I don't know, Circle K increases their prices. What's going to happen to the quantity demanded for Speedway's gas? Well, Circle K's prices are higher. What does everyone going to want to do? Buy from Speedway, right? Buy from the other gas station. So when price and quantity moved in the same direction, or when our cross price elasticity of demand is positive, right? They're positive change over a positive change. Here, this would be an example that we have substitutes. Now, what happens if the price of another good goes up or a positive change, and as a result, I buy less of this other good? So this would be the idea. This is how I always think about complements. Anything that requires batteries and batteries, right? I sometimes will use like a clicker in class to go through slides. I stop because it's not compatible. But if batteries all of a sudden cost $100, what's going to be true about my demand for these clickers to kind of go through my slide. It's going to plummet, right? Because I need batteries to use it. I have to buy both of those. So when the price of this other good went up, batteries goes up. Anything that requires batteries, my demand for it goes down. Well, positive over negative, my cross price elasticity would be negative. So anytime I have a cross price elasticity that's negative, that would represent these two goods are complements. So the cross price elasticity, the sign of it tells me whether or not these are substitutes or complements. Any questions on this idea? Yeah.
So if good Y, if the price is good Y increases, Y would be that saying that the price is good X also increases?
Not the price, it's just the demand for good X. So remember, we said when the price of a substitute good goes up, what happens to the demand for good X? So if all of a sudden, I don't know, let's say, well, we could use my example from earlier. Let's say all of a sudden, for whatever reason, the government wants you to stop using tobacco products, but they don't really care about nicotine. So like they're taxing these tobacco products like cigarettes and the prices are going way up. What's going to happen to things like nicotine pouches? People are going to stop using cigarettes and start using some other nicotine products. So the price of tobacco of cigarettes going up, what happens to the use of these nicotine pouches? It would go up, right? That's that idea. The price of some other good was changing, and as a result, the demand for this substitute product also went up. Any other questions on this? So all I'm going to expect you to know is that the sign of the cross price elasticity tells you if there's substitutes or complements. What could I also start to break this down into? So with price elasticity of demand, we had two regions. We kind of had this, if it was between 0 and 1 or above 1. So what could I do with my cross price elasticity of demand? I could figure out if it's pretty inelastic or pretty elastic. That would tell me about how strong of complements or how strong of substitutes they are. I'm not going to expect you to know that, but just sometimes I like to mention kind of like what the next step would be if we had like an intermediate micro. We might dive into that issue a little bit further. So I just want you to know that the sign tells you if they're substitutes or complements, and then the magnitude, how large that cross price elasticity of demand is, tells you about how strong of substitutes they are or how strong of complements. If it's closer to 0, do you think that tells me if they're strong or weak substitutes or strong or weak complements? Weak, right? What would 0 cross price elasticity mean? That when the percent change in good Y causes a no change in good X, well, that must mean that they're completely unrelated. They're not substitutes or complements. So, right, the magnitude of that cross price elasticity would basically just tell me how strong of substitutes or complements they are. But we're just going to really care about the sign, okay? So unlike the price elasticity of demand, we don't take the absolute value here, right? The sign tells us something. With the price elasticity of demand, we always knew that the sign was negative, okay? Any questions on this before we keep moving here? All right. So I've got another one that we can think about. Well, sorry. And let me make sure I match. Nope, that's not how I wrote it in the slides. I'll use this notation. So for whatever reason in economics, we typically use M to represent income. I, tends to represent other things. And so we use M to represent income, right? So if I wanted to know my income elasticity of demand, once again, this is why I set up last class, thinking about how do we interpret this? We said it's always going to be the responsiveness of this second word. So it's the percentage change in the quantity demanded. Instead of responding to price now, though, it's going to be how responsive is demand to percent changes in income. Right? So we can kind of do a similar thing. If I see income go up, and as a result, demand also goes up, my income elasticity would be positive over a positive, right? So it would be positive. What type of good would this be? When I have more money, if I demand more of it, we said that was a, normal good. If I ever have an income elasticity where when I see an increase in income, I actually see people buy less of it, I'd have a positive change, or sorry, a negative change over a positive change. So if my income elasticity is less than 0, that tells me this good is a not normal, but when I have more money, if I buy less of it, an inferior good. So this is how we identify whether goods are normal or inferior. We don't just use our intuition. Our intuition helps, right? We think things like public transportation probably is an inferior good, but we can actually measure the income elasticity, find that it's negative, and that's what gives us support to say it's an inferior good. Any questions on that idea? Yeah.
So regardless of if there's one negative on the top or bottom, that shows if it's a complement or inferior.
Yep, we just care about the sign of this elasticity. So you could do the other way. Let's say I had a decrease in income. If I had an inferior good, so this is going to be a negative change. If it was inferior when I have less income, what's going to happen to my demand for that good? I'm actually going to buy more of it. So positive over a negative would still give me a negative elasticity. So it doesn't matter which direction income changes, right? I know that even if income goes up or down, my income elasticity will be negative when it's an inferior good. And then same thing will be true for a normal, right? There, if I see low decreases in income, what happens to the demand for a normal good? It also decreases. Negative over negative would be positive income elasticity. Okay. Other questions on this before we keep moving here? Okay. All right. So kind of, like I said, sometimes I've got things in the slides. I like to kind of write them out. These are just kind of good to go back to for a nice summary. We had our cross price elasticity. If it was positive, it told us they were substitutes. Negative complements. Income elasticity. Positive told us they were normal goods. Negative told us they were inferior. I'm not going to ask you any questions on this, but it is somewhat interesting. I put an article up if you're a little more interested in this. They kind of measured this. So we usually have a range for the price elasticity of demand to say if it's elastic or inelastic. So if we have an inelastic income elasticity, so this would be an income elasticity that's somewhere between positive. So it's only for normal goods. So it's somewhere between 0 and 1. So normal goods, we said the income elasticity would be positive. So if we end up with an income elasticity between 0 and 1, we would call these kind of necessity goods. So these are goods that, yes, when I have more income, I do want to buy more of them, but like I just needed some base amount to survive. So even when I have more income, I'm not going to buy that much more. So an example might be something like electricity. When I have more income, I might be a little bit less likely to like remember to turn my lights off when I'm leaving, or I might, leave something running and not worry about it too much. But when it comes to heating my house, regardless of how much income I have, I'm going to use the same amount of electricity probably to heat my house, or at least pretty close. I'm not going to be that responsive to changes in income. So like my wife, she would keep the thermostat at 67 degrees in our house if we had $0, if we were making a very low amount or a very high amount, right? It's pretty inelastic. It's a necessity good. Heating your home is generally pretty close to a necessity good. That income elasticity will be pretty close to 0. Now, for luxury goods, right, this is going to be things that are really responsive to income changes. So we call these luxury goods. Think about why. If I have an increase in income, right, in order for my luxury good, oh, sorry, I have it. I copy and paste. This is not, oh no, this is right. I just have it back. I should have wrote it. Why did I do this? Sometimes, I don't know. There, it says the same thing, but that's really how I should write it mathematically. When I have that income elasticity is greater than 1, what would have to be true? Well, if I'm looking at my income elasticity, in order for it to be greater than 1, that would imply the percentage change in the coin demanded is greater than that percentage change in income. How do I get really large percent changes in coin demanded? Well, if I start out at 0 and I go to 1, that's always going to be what? A small or large percent change. I mean, technically going from 0 to 1, if I use 0 as my base, any movement away from 0 would actually be a infinite percentage increase, right? Now, if we use the midpoint method, it's not going to be infinite, but it's going to be very large, right? So when it comes to these goods that people generally don't have a lot of, we usually only have like one of them, or luxury goods. So this might be things like, what did I use? You know, a Ferrari, Rolexes, new homes, right? People generally go from 0 to 1. Increases in income, right? We generally are going to see really large, even small percentage. We might see really large percent change in quantity demanded if we're going from 0 to anything. So anything that's above 1, we would kind of call these income elasticities for normal goods luxury goods. Now, once again, really just going to want you guys to focus on identifying, are they normal or inferior? I'm not going to make you identify this, but it is an interesting kind of discussion to have at this point. And also lets me use the cheesy meme I found at one point in time, which is your income elasticity greater than 1? Because being with you is a luxury good, right? Valentine's Day is coming up. Feel free to use this, okay? So I'm not going to go over this one too much because we've really already talked about it. If I want to do the price elasticity of supply, I literally calculate it the exact same way as the price elasticity of demand, except for what? Instead of the percent change in the quantity demanded, I would use the percentage change in quantity supplied. It's going to look no different. The only difference is I didn't have to take the absolute value. Why? The price elasticity of supply, if I increase the price, quantity supplied should always be going up. It's always going to be positive. So I don't have to worry about the negative sign there. Okay? And then the ranges are the exact same. In between 0 and 1, we would say price, supply is pretty inelastic. Anything greater than 1, supply is elastic. Equal to 1, supply would be unit elastic. Now, we don't have anything to talk about with the price elasticity of supply in relationship to like total revenues. So we don't really have to worry about that. But yeah, we don't have a whole lot new here. It's using the midpoint method the same way. If I gave you 2 prices, 2 quantity supplied, plug it in the exact same way we did for demand. It's just we have one less step, which is we don't have to worry about taking the absolute value. Okay? So nothing have to reinvent the wheel here. Any questions before I keep moving on this? Trying to keep an eye on time here. I think I know what I have left. Okay, perfect. We are exactly where I want to be. So let's think about some of the features that would impact the elasticity of supply, just like we did for the elasticity of demand. So anything that makes us as producers more apt to be able to respond to price changes, like it gives me more flexibility, that's going to make my elasticity. I can respond more, so my elasticity is going to be higher, right? I mean, more elastic when the price changes. So what does this look like for producers? So a lot of the times we'll think about this as like, if I have extra capacity in my plant, so why might a company want to buy a plant that's larger than what it currently needs based off of what current demand is? Well, because they might expect things to change in the future. They want to have the flexibility that if the price of a product goes up all of a sudden, if I'm constrained, I've already maximized my capacity in my plant. When the price goes up, what can I do in terms of how much I supply? I've already maximized, I can't respond at all. So allowing myself to have some like extra capacity allows me to respond to price changes. When the price goes up, I can then produce more or supply more as more. All right, if I choose a plant where like I'm already maxing it out, I'm producing as much as I possibly can. When the price goes up, I can't produce anymore. I'm already maximizing. You might think about also, making sure what's something else that even if I am currently in a plant, if prices go up all of a sudden for whatever good I'm making, what might I want to do? Not stay in the same plant, but move, right? Well, what makes it harder to move? If I'm locked in to like a lease contract, if I don't own the production facility, I'm just like renting that space, it's harder for me to then relocate to a larger facility, right? So what do companies not want to do if they're signing contracts or they're signing leases? Like, let's say I'm doing like a really small thing, like, I don't know, I'm producing you go to like these arts and crafts shows, and like people will be like, I don't know, my wife likes them when we go sometimes, like, they're producing like goofy handbags and things like that, and they're doing it out of like a really small shop. Well, all of a sudden it takes off, some influencer posts their stuff, and now they can move. Well, if I'm locked into like a 10-year lease on a building, that's bad, right? Because now I get out of that, I'm gonna have to pay that, no matter what. If I want to move to a larger production facility, I'm gonna have to end up paying 2 years, right? So kind of allowing yourself flexibility, being locked into lower kind of year contracts would be ideal for these suppliers. And then kind of similar to demand, if I have more time to make my production decisions, what should be true about the elasticity of supply? If I have more time, I can be more responsive or more elastic. Same kind of thing with consumers, right? If I have less time, right? So let's say all of a sudden, someone shows up in the town and they're wanting to buy up every single, unit of whatever product I sell. Well, if I have to get over to this place where this person is right away, well, I can't be very responsive. Now, if I know that someone's going to be here the next 2 weeks and they're buying up whatever product I'm selling, I can be a lot more responsive into how much I'm producing and how much I'm supplying to that person. That's a kind of a goofy example, but that's the idea of kind of more or less time. Excuse me. So if I'm a supplier, what would I want to make sure is true about my production facility? That I can produce things so if I want to, prices go up as a supplier, I want to be able to make sure I can respond to those and produce a lot more and sell when the price is high. So what do I want to make sure my workers can do? Produce things very quickly, right? That's why I want to make sure I might have checks along, I make sure everything's working efficiently, smoothly, so that when I do want to ramp up production, I can do it almost immediately. Right? So time impacts the price elasticity of supply the same way it impacts the price elasticity of demand. Doesn't really work any differently. More time, I can be more responsive or more elastic. Okay. I then have an example I think is interesting. So tragic example, but kind of take what we're learning in economics and apply it to the real world. So in the 90s, someone did this kind of small study of Sudanese slavery. So all these humanitarian groups were like, oh man, this is terrible. They're enslaved, there's all these slaves in Sudan, let's go over and free them. So they're going over, they're willing to kind of buy, right? Pay for these slaves' freedom. That seems like a really good thing, right? But what happens if there's more people willing to buy these slaves' freedom? Price is going to go up, right? So if I'm offering higher prices, I'm this humanitarian group, and I'm coming in and I'm offering higher prices than what currently people were paying for those slaves, right? To actually have, enslave those people. If I'm offering higher prices, what happens to the supply of slaves? It increases. So when you have these humanitarian groups coming in trying to pay and free the slaves, what happens in Sudan? People are going out and enslaving, trying to find more people to enslave to be able to sell, right? So what they actually found was these humanitarian groups, because they were increasing the price, they actually increased the supply of slaves in Sudan in the 90s. They were actually exacerbating the problem, right? So they're well-intentioned, right? But they didn't understand basic economics. When you go in and offer these higher prices, automatically what's going to happen? Supply is going to increase, right? Or we're going to move up that supply curve. Now, how much, right? Well, it depends, right? Well, I ended up in this example, they were kind of looking at some of the backup old data. They found that actually the slave supply was fairly elastic. So that when these humanitarian groups came in, even though they were only offering to pay a slightly higher price, if supply was very elastic, that small percent change in price led to a large percent change in the quantity supplied. Well, here, that's a really bad thing because there was a large percent change in the quantity supplied of slaves in Sudan, right? So just kind of a, I don't know, unique example, thinking about what we're talking about, kind of how it applies to some of these real world kind of issues. Yeah.
Does it mean less slave owners are actually able to purchase them now that the price has gone up? Are able to purchase slaves?
So yeah, you might reduce slavery. Like these humanitarian groups did free a lot of slaves, but if the price is high, what probably happened to a lot of those people? Once they were set free, they were just caught again and put back into kind of the market and sold again at these higher prices. Yep. So it didn't really solve kind of the issue. So kind of an interesting example. I have an example here, which for the sake of time, I want to make sure we get to that in-class quiz. But I thought it was kind of interesting, and I put the link so you can always go back and look into it. They ran this experiment where they found a bunch, I forget what city this is in, they found a bunch of heroin users. And did this like economics experiment with them and offered them, like, if I charge you this various prices, how much of these different goods would you buy? So they were kind of interested in, for whatever reason, do we have substitute or complementary use in heroin and these other products, like what? They did cocaine, marijuana, and beer. And they like measured, okay, at these artificial prices, how much do these people respond, these actual heroin users, how much do they tell me they would buy if they had that much money? They then had different price, they changed the prices of these different goods so that they could measure cross-price elasticities. They could also measure the price elasticity of demand. What do you think is probably true about the price elasticity of demand for heroin? It's going to be pretty, I'm a heroin user, I'm addicted. Price goes up, what happens to my usage? Well, it's less, but I'm still probably using about the same amount of heroin. Like, I'm pretty inelastic if I'm addicted to something. Right? Now, the cross-price elasticities, right, they actually found were negative between cocaine and heroin, which are telling me that for cocaine and heroin, they must be what? So if I have a negative cross-price elasticity, that meant when the price of cocaine went up, what had to happen to the demand for heroin? If it's negative, that means that the demand for heroin actually went down. So that would tell me, if they were negative, that when the price of cocaine goes up, the use of heroin went down, they must actually be complementary goods for these heroin users, right? So I don't know what the story there is, right? You need an upper and then a downer, or vice versa. But we still have one thing before you get out of here in the next couple minutes. And I'm actually going to go in just to make sure this due date and time. Oh, that's not what I want. Oh, because that's not the in-class quiz. There we go. So I'll just extend this to make sure the submission isn't an issue for anybody as you're kind of packing up and getting out of here. All right. So we'll kind of get this published. Next couple minutes of class here ended out. You can find it. Right here on the home page or under the quiz tab. Kind of go through this pretty quickly here, get us out of here by 9:15. All right. So if I had this example, I'm looking at cigarettes, and I've got that the price elasticity of demand is 0.4. So that tells me that demand is what? Elastic or inelastic? Inelastic. So if I raise the price from $4 to $5, so that would actually move me back up my demand curve. So if I start out with demand being inelastic, moving up the demand curve actually moves me closer to the unit elastic point. What's true about revenues at the unit elastic point? They are maximized. So if I'm moving towards that point by raising the price here, what must be happening to total revenues? They're increasing. All right. What if I had kind of this cross price elasticity of negative 3.2? Well, we actually just talked through an example, heroin and cocaine. We said that when the cross price elasticity is negative, the price of cocaine went up, people used less heroin. That means they must have been complementary goods. Right? So the sign will kind of tell us whether or not they're substitutes or complements. Here, the only way that we have negative is if that percentage change in the price of good Y. If it's 3.2, right? What's the only way that I can get it to be above 1? That numerator must be larger. So it must have been that the percentage change in the price of good Y was actually less than that numerator, right? Less than the percent change in quantity demanded. So once again, sometimes I'll give you these answers because I run out of time because I talk too much. I have this kind of set so you get it submitted by like 9:18. So before you get out of here, the only other thing, there's no right or wrong answer here. I've got it set to be module 1. I'll change it after class so that it just gives you full credit for whatever you respond. I just want to know which of these modules would you most likely want to see reviewed on Tuesday. So module 1, 2, 3, or 4. There's no right or wrong answer to that one. I know I haven't got one selected. You'll get full credit for just responding to that third question. Okay. Other than that, a fun, safe weekend. CL sessions tonight and Sunday. And other than that, I'll see you guys on Tuesday.